Hello. Today we're going to talk about high-quality programming, and we'll try to review to you some of the positives of self-documenting code. My name is Hristo Radkov. I'm a senior technology architect at Clever IT, which is a company based in United Kingdom in London, offering consultancy on software development, architectures, and best coding practices. We're providing this video for you in association with Telerik Academy and Svetlin Nakov and Telerik Corporation, and today we're going to discuss what high-quality programming code is about. We'll mention external and internal code quality, also how to name identifiers in the best possible way, like classes, interfaces, methods, properties, structures, and others. We'll elaborate a bit on how to do best code formatting, and we will also discuss how to design high-quality classes with the use of object-oriented principles. We'll mention abstraction, encapsulation, inheritance, cohesion, best practices. We'll discuss when to create a few new methods to an existing class, or when to create a new class and put the new methods into the new class because they belong to that class better, and when to create base class, when to not create a base class and extend it, and other modeling principles around that. So, what is high-quality programming code? Well, to consider code as high quality, first of all, it has to be a very good purpose fit. It needs to have the correct behavior in all the use cases it covers, and it also has to be very well tested. It needs to be well architectured and well designed, and what in our current programming world is very important, the code to be adaptable to fast evolving business requirements, so it has to be maintainable. To be maintainable, it needs to be easy to read, easy to understand, and easy to modify. It has to be well formatted, well documented, and best when it is self-documenting code. It also is very important the complexity of the code to be minimized, so the amount of code we have to go through to safely create a hotfix or implement a whole new change request is minimum, without the need of a full regression test or without the need of going through the whole code. And that in fact brings us to complexity management, which is a key to be an effective programmer in today's world. We should always aim to maximize the portion of the program that we can safely ignore while working on any section of the code. For example, in today's world's engineering, a car is being built out of many compatible parts, which interact together, forming a common system, which is the car. Each part is self-sufficient, and each part has an interface to connect to the other relevant part it works with. And the car actually sticks together, though being created by separate parts and all of them being designed in different places around the world. In fact, there is another even better example. When we have a flat tire of our car, what do we need to do? Do we need to change the whole car? Do we need to throw the whole car? No. Well, that doesn't mean that we can drive the car is not working because there is something wrong with it, but we don't really need to change the entire system, which is the car. All we need to do is inflate the tire, and we don't need to inspect the engine, we don't need to check the wipers, we don't need to check the lights. All we need to ensure is that this part, which is self-sufficient, is working properly. In development engineering world, it is actually the same. We're trying to create self-sufficient pieces of code with the key idea to manage the complexity. all we're trying to achieve by that is to minimize the amount of complexity that anyone's brain of a software developer has to deal with at a certain time. And that imposes architecture and design challenges, which means we have to think more when we design than just typing our code, which many developers prefer to do. Starting typing, starting coding, without paying too much attention to the design. But actually, without that, you cannot be a cost-effective programmer. So that creates some code construction challenges for us, and we have to apply best software engineering practices for anything that we do, like classes, methods, variables, naming, statements, error handling, formatting, commenting, and other. Right, let's talk about external and internal quality very quickly. What external quality is? Well, this is everything that we can touch about software without going into the code. So we can check, does the software really behave correctly? Are the produced results correct? Does the software run fast? Is the software UI easy to use? If the software has UI indeed, because it could be simply a web service. When we want to deep dive a bit further to get an idea of how maintainable the software is, we obviously need to go into the source code. We can check if the source code is easy to read and understand. That's the first and obvious impression that we can get. Is the code well structured? Is the code easy to modify? Okay, so we spoke about software quality, we spoke about other interesting things like cars and car parts, but we're software developers, so what we usually like to see is some code. Well, here is a beautiful piece of code for you. This is what I usually call spaghetti code, because it is so mixed up that it's extremely hard to understand. And believe me, this code actually is fully compilable, because the compiler syntax and punctuation rules have all been followed. But can you understand what this code does? Can you tell me if it does it correctly? Let's have a look at the same code, just being a bit better formatted, and see what the difference just the formatting does. So coming back to our beloved spaghetti code, and the same code being formatted. So now we can go through each line, we can read it and try to interpret ourselves what instructions are going to be passed to the compiler. So we are a step better, but the code is still unclear because it's just not documented well, it's not written in a way that we can easily understand what each variable is meant to be doing, and it's still hard to guarantee that the code is going to work properly. And this is why best practices come into place indeed, to address any issues like that and go a step further from just a good code formatting. So going this step further, we obviously need to have a set of formalized code conventions which we can all follow, and ideally all these could be followed by everyone all over the world. So what are code conventions in .NET? Well, there are formal guidelines about the style of source code. They suggest some rules around code formatting, like indentation, white space, braces, parentheses, punctuation, where to put new line, where not to put, and so on and so on. There is a set of naming conventions to aid the quality of the identifiers, like classes, interfaces, enumerations, structures, constructors, fields, operators, and all other. And these conventions often use Pascal case and camel case. So what is a Pascal case notation? Well, it's a notation where the first letter of a variable is capital, and if the variable contains multiple words in the name, each word starts with capital letter for better readability. Like, for example, Pascal case is 2 words and each word starts with uppercase letter. Camel case, on the other side, is exactly the same as Pascal case, but starting with lower case letter, like in the example of camel case. Suffixes, a good example for suffixes usage is exceptions classes, where they have the word exception added to the end of their name. An example for that is found not found exception. So all these aid the quality of the code. To formalize the code conventions is a good start, but if everyone in the world has different code conventions, that is making it a bit difficult. So it's best if these are published and as many people as possible try to use them. So Microsoft has defined official set of code conventions. They've coded design guidelines for developing class libraries, and you can see the link on this slide. Most of these conventions give a very good start, but they are by far not sufficient for everything. So most developers follow these conventions and recommendations, but they have to extend them. So this video will give you a good extension of Microsoft guidelines and a good overview of many good code conventions. Excellent. And now this is indeed taking us to the most interesting part, which is naming identifiers. Talking about them, there are a few things to be mentioned. First of all, always use English. English is the common language that almost everyone in the development world understands. So if they don't understand English, they can't really be very good developers, because all the documentation is in English, and basically without having documentation it is very hard to develop. I had personally a situation when I had to look at some code to analyze its quality, and most of the methods and operations were written in German. And poor me, I don't know German very well. So I had to actually go through the code with a dictionary and try to understand various bits, and basically probably spend 3 to 5 times more than I would usually spend if I was looking at a normal English written namings. So avoid using namings in your language. Always use English, so your code is better understood. Avoid abbreviations, because abbreviations actually don't help at all in today's development world. Yes, in C++ long time ago, when the code editors were not as advanced, that was kind of helping to save typing time. But now, as we have IntelliSense in the development environment in Visual Studio, it simply doesn't make sense to abbreviate anymore. So use scripts count instead of scrpcnt and other examples like that. Also try to avoid hard to pronounce names. Like in this example here, the name DTBG regex ptrn, what does that really mean? You should always try to use meaningful names. Names should answer the questions: what does this class do? What is the intent of this variable? What is the variable class used for. Like, for example, a good name is factorial calculator, students count, math.py, config file name, create report, and but names would be k. So what does k mean? Not clear. K2, K3. It's not good to use numbers, they don't add quality. Using words that are meaningless like junk, F33, KJJ. Button 1 is a good example that we have probably all encountered on, where instead of renaming the button to what it is doing, like button submit, it's just called button 1. So it's not very clear by just looking at the code what button 1 does and what it is responsible for. Using names like variable, which is non-descriptive and meaningless, you should try to avoid that. Names like temp, var, something, some value, all these names are meaningless. Sometimes for shortness and conciseness you can use meaningful names within a context. Like, for example, in the context of file finder class, the method find is clear enough. You don't need to name the method find files or find file, because it's clear that within file finder the find method would be finding file. A method generate in report generator is also clear within the context, and method deposit in the context of account class is also clear. Method generate is not as clear in the context of a class called program or class that is not clearly defined. So see the difference. Report generator dot generate, quite clear. Program dot generate, not really clear what does it generate. The same with program dot find file name. It's not really clear what it is finding. There are some but names which sound still meaningful but are not appropriate, and junior developers often try to use them. Like a but naming example is problem 7. So I just started work, now is 7th hours of my day, so why don't I call my task problem 7? Will the boss be happy? Well, in fact, the boss will be happier if you name that report generator, because the boss gave you a task to write a report generator. So when we're naming types like classes, structures, what are the best practices for naming them? First of all, we have to use Pascal case, which we discussed earlier. This is the one starting with uppercase, and each word being concatenated starts also with uppercase. Examples, good examples are recursive factorial calculator, tree set, XML document, IEnumerable, color, tree node, invalid transaction exception, main form. And but examples, recursive factorial calculator starting with lowercase, which is actually the camel case notation instead of Pascal case, which we should be using here. Recursive underscore factorial underscore calculator, that's not really Pascal case again. Recursive, all upper letters, recursive underscore factorial underscore calculator. This is more appropriate for a constant, and we'll see further in this video that constants are defined like that, but it's far inappropriate for naming a type. why are we trying to name the classes and structures like that? Well, classes and structures generally represent some subject, something that can normally in the normal life can be touched. So that's why it is a noun or adjective plus noun. And here are a few good examples of nouns and adjective plus nouns, names of classes and structures like student, like file system, binary tree node, constants, matutils, text box, calendar. And a few bad examples inappropriate for naming a class, like move. Well, move really represents an action, an activity. So it's not a subject. It can be called mover or anything around move that is a subject. Find users, again, this implies an activity. If you call it user finder, then that's more appropriate for a class and structure name. Fast or optimize are again inappropriate. In the case of optimize, which is more an activity and a good name for a method, but not for a class. To make it appropriate for a class, we might want to call it optimizer or some subject around optimization. So that gave us a few good examples of how to name classes and structures and how not to name. Naming interfaces is a bit specific because we always have to start with I, and that actually in the interface notation represents a prefix for interface. So this is an example of using a prefix. Then normally an interface name could contain a verb and a suffix able, or it could be I plus noun or I plus adjective plus noun. And here are a few examples of good interface names like I enumerable, I formattable, I data reader, I list, I HTTP module, I command executor. The last being an I plus adjective plus noun, I data reader being I plus noun, and I enumerable being the first representation of interface name with verb in the middle. Some incorrect examples that are probably more helpful to you. Interfaces names cannot start without I, so list or find users are inappropriate. I fast doesn't really make sense because it has to be a noun. Fast is more of an adjective, so it is missing what the interface is really doing. It's not clear. iMemory optimize. Again, that's not a good name for interface. A better name would be iMemory optimizer. Just optimizer, again, without the I, it cannot be an interface name. Checkbox, you can have an I checkbox interface if you like, but you can't have an interface name without starting with I. Rules and best practices around naming enumerations. So the following formats are acceptable: either a noun or a verb or adjective. The use of the same style for all members is required to make it concise. Like in the examples with enumeration for day, Monday, Tuesday, Wednesday are of similar style. For enumeration upstate, running, finished are a good representation of the same style. In enumeration called window state, normal, maximize are a good example. In enumeration called color, red, green, blue, white would be good example if they were uppercase. And enumeration called page_format, we don't name enumerations like that. Enumerations are named like classes, like structures, following the Pascal case notation. And it doesn't really make sense to have in your enumeration variables like A4, A5, A3, and so on. So enumerations are a special type, and they're not the only special type in our daily .NET programmers world. There are other special classes like exceptions, like delegates, like attributes, and other. So when we have exception, for example, we add exception as suffix, and that allows us to know that the type of special class is actually an exception. A good example is found not found exception, which would not make sense if it was called found not found error. It should be a very bad example. When we have delegate classes, in a similar way, we add a suffix, which is suffix delegate or suffix event handler. And a good example is download finish delegate instead of wake up notification. Well, does wake up notification really imply that the download is finished and that you're going to be notified that the download is finished? Not really. So that's why it is not a good name. We have similar notation around attributes where the suffix is attribute and other special classes. So that gives you the idea of how to deal with these. When we are trying to define a name for a new class, we should consider how long the class name should be. In fact, if we encounter on a too long class name, maybe our class name is not doing only a single thing, and you should probably consider whether you should not add parts of the class somewhere else into another class. But in fact, you can use as long as necessary names, and don't abbreviate, because abbreviations, we know, don't really help. Some good examples are found not found exception or customer support notification service, still acceptable name, instead of FNF exception, which is not very clear what FNF is, or cust support notif, cust sub notif SRVC. You see, it's hard for me even to pronounce that. It's much more readable, even though it's long, to say customer support notification service. So that's about the length of class names. Use as long length as necessary. Always try to keep it as short as possible, and don't expand if something doesn't really add clarity to the name, but never abbreviate. Naming namespaces. Some of the key guidelines around that is always use Pascal case. There are some examples of good formats that are acceptable, like starting with the company, then subnamespace for the product, then subnamespace for the component, and so on and so on. Or just ignoring the company and starting with the product name and then component and so on. For example, starting with the company, Telerik, then .product wing controls, then .component grid view is a good real-world example. Incorrect usage would be Telerik _ wing controls grid view or just classes, because classes doesn't really qualify and it's not very meaningful because everything is a class. So you would always put in such a namespace a class anyway. So if you're going to write to name a namespace classes, you should consider what are you planning to put in this namespace. If it is utilities, better call it utilities. And in the first example, just using the underscore, while the compiler would accept it, it's not a good usage, and it doesn't allow us to get some quality from the namespace. Naming assemblies. Well, generally we name assemblies after the namespaces. Like a good example is telerik.wincontrols.gridview.dll or oracle.dataaccess.dll or interrupt.capicom.dll. And bad examples is same as we had before with .dll or oracle dataaccess.dll. And these examples are completely compilable, but they're just not very good way of understanding what namespaces are contained into this DLL, and implies bad practice and bad design sometimes. Right, well, how about methods? What are the guidelines there? Well, as with everything else, method names should be meaningful, first of all, and they should answer the question, what does this method do? What is the action, what is the operation that this method is performing? Good examples for a method is find student, load report, sinus. And have in mind that if you cannot find a good name for a method, you should probably think, does the method have clear intent? Does it really do only one action? Because it's always a good practice if your method is responsible for a single action. And if you find that your method is doing several things like creating a report, sending an email to notify someone, and any others that are not related to the report, you should have two methods: create a report and send a report notification, instead of having one method defining the code functionality for creating a report and then defining the whole functionality about sending an email using the email protocols and other bits. So here are a few other bad examples that will help you orient how to not name methods. Like method 1 is a bad example, similar to our previous button 1 example, because you can't really infer from the name what the method is doing, what its purpose is. A method called do something doesn't really make much sense, or just method called do or go doesn't really make sense. Handle stuff, again, meaningless name. Sample method, anything with method in the name doesn't really make sense. Dirty hack, well, that is to some extent meaningful, but would be much nicer if this dirty hack had some name. So it is completely clear from the method name what it is about. For methods, we should always use Pascal case, and here is a quick example: load settings with uppercase instead of load settings with lowercase, which is used in the JavaScript notation, for example, or in Java for methods and functions. Methods should normally contain a verb, or a verb plus noun, or a verb plus adjective plus noun, Like for example, show is a good method name, world settings file, or find node by pattern, or toString, or print list. And bad examples would be student, because student is actually more appropriate for an object name, or counter, again more appropriate for a class name, white, again more appropriate for class name or some enumeration or for something else, but as all these don't contain any action and a verb, they cannot be good method names. The same around generator, approximation, and matutils. Sometimes your methods return values, and it is always a good practice when the value that is being returned is described in the name of the method. Like a good name would be convert meters to inches instead of just convert or convert unit or meters inches. Sometimes convert meters 2 inches with using the number 2 can be acceptable, though I wouldn't say it is recommended. Sometimes some abbreviations are also acceptable, or some exceptions from the rule, when it is very clear from the name that it is doing an action, some certain type of an action. Like instead of calculate sinus, you can sometimes just use sinus, and because in the context it is clear that it is going to calculate sinus, it can be inferred that this method is actually doing a sinus calculation. Sometimes I've seen methods that are not very clearly explaining the type of measure, the unit of measure that they're going to convert things from and to. For example, in this last case, measure font in pixels is much better compared to measure font, because the font could be measured not just in pixels, it could be measured in points and in other means. So it's always better to indicate what you're measuring the font in. Especially sometimes you might need to have a few methods for measure font, one in pixels, one in points. So if you didn't have that, your methods would have exactly the same names, and that would make them quite confusing. As I started mentioning earlier, methods should have single purpose, and they should perform a single action. Otherwise, they cannot be named well. Like, for example, how to name a method that creates annual incomes report, downloads updates from internet, and scans the system for viruses. Can you really have such a method? How would you name create annual incomes report, download updates, and scan for viruses? Oh, that's a really nice name, but it's a bit confusing. So methods that have multiple purposes are hard to be named, and when a method has multiple purposes, we say that it has weak cohesion, so it's not cohesive enough. They need to be refactored rather than being renamed. If you want to have some consistency in methods naming, first of all, try to use consistent naming in the entire project, like using consistently the opposites, like vote, unvote, like open, close. Also try to use consistent naming in the entire project in terms of vote files, vote image from file, vote settings, vote font, vote library, instead of somewhere all of a sudden to start using the word read text file instead of vote text file. In the other examples, like Vault library and unvault library should be used instead of free handle as the meaning of unvault library, because it's much easier for the reader to understand that unvault library is just doing the opposite of vault library. Close file versus open file. We shouldn't use the allocate resource for saying that file is closed. It's better to use close file when you have used open file earlier. Get and set are similar example. It's better to use get name and set name instead of get name and assign name. And saying all that, we are now coming to the recommended length of method names. So how long could the name of a method be? Well, generally, as a good practice, the names of variables, methods should be between 9 and 21 characters where possible, because that's what most of the people's eyes manage to read within one glimpse. But sometimes that's not enough for naming a method, so if you can't stick within this rule, try to name it as clear as possible and make it as long as necessary, really. But do not abbreviate. Never abbreviate, because anyway the development environment, Visual Studio, will manage to autocomplete for you. And not just Visual Studio, but most of the development environments. Some acceptable examples are create monthly income report or even Vault customer support notification service. And bad examples are examples where we have abbreviations like Vault cust sup and other abbreviations in the names. When we're naming methods, we also sometimes have parameters in these methods, and these parameters are actually variables. These variables are similar to classes instances, structures, and other type of intrinsic variables, but they are all local for the method variables. And because they are variables, they are something tangible. Their form would normally contain a noun or adjective plus noun. So the names should be meaningful always, so that applies to any type of naming. And because the variables are local for the method, the parameters of a method are always local variables, they are named in camel case. Here are a few examples, like first name starting with lowercase letter, report, user list, font size in pixels, font name, and just font as a variable instance of class font, let's say, or a structure font. Some incorrect examples here would be again abbreviations or meaningless names like P, P1, P2, where a number is used which is not recommended and it is too short and unclear. Populate would be more appropriate for the method name, not for its parameters. Last name with capital letter, that's wrong, because here we have a variable that is private to the method context, so it is not camel case notation where it has to be camel case notation. Last underscore name is bad naming, because again it doesn't fit into camel case. Convert image is a name that implies an action, so therefore is not appropriate for a method parameter. So how to name other variables? Well, variables similar to the parameters of a method should be in camel case. And again, the preferred form is noun or adjective plus noun. As usual, they should explain the purpose of the variable, so they need to have a meaningful name. And if you can't find a good name for a variable, you should consider, does it actually do a single purpose, or is it fulfilling more than one purposes? And in such a case, you should define as many variables as you need, so they actually have single purpose. There are some exceptions from the rules, of course. Some variables that are with very well-known names, and like I, for example, for iterating for a loop. And when they are in a very small context, sometimes it is clear enough to name your variable with a few letters or one letter, so it is a bit shorter. But again, this is not really the recommended practice. It is acceptable, but not really the recommended practice. And let's not forget that your names should always be consistent through the whole project. So where you're using get and set, make sure that you're using them properly, vote, unvote, and stuff like that. So examples for naming variables: first name, report, users list, font size, I'll go a bit further, chars count, config settings XML, config, DB connection, SQL command, create user. Some bad examples would be foo, bar, where it's not very clear what these variables are doing, though bar in the context of representing an instance of a class called bar might make sense, but in all other cases it won't really make sense, unless we want to go to the bar and have a drink while we're doing some development. Names like P, P1, P2 are generally bad. Named like populate, which represents an action, is more appropriate for a method, but it's also lowercase, so not good name for a variable. Better name would be population, for example, because that's a noun. Last name with Pascal case notation would be wrong. Last underscore name would be wrong as well. Last underscore name with all capitals would be wrong, because that more denotes constants, not variables. Convert image more looks like a method name. Of course, if it were a method, it had to be Pascal case, not camel case. Move margin again contains action and doesn't make sense. Max speed would be a good name, but max should be abbreviated a bit more properly. And usually when you have max speed, you might want to actually move it as a constant. So if it is supposed to be a constant, it won't make sense to name it like that. Underscore first name, underscore temp. I have seen naming some variables with prefixing them with underscore. Even I believe I've seen that in some of the codes written by Microsoft. But that's why we're saying that sometimes some best practices have some exceptions, and we should try to avoid this type of notation, though you might meet it somewhere. First name, middle name, and last name. That's a very good example of a variable that actually contains several things. So why not separating it into 3 variables: for first name, for middle name, and for last name? Or if you want this to contain a full name, just call the variable full name. The name should always address the problem that we try to solve in the variables, not to contain how we're going to solve it. Like good names would be accounts, customers, customer address, account holder, payment plan, VIP player, instead of accounts linked lists, indicating that we're going to solve the problem with the accounts by putting them into a linked list, or customers hash table, or payments priority queue. Certainly, if that adds any further meaning to your name, then you can leave it as payment priority queue. But if it is just to say what the type of the payments object is, don't use that. When we're naming variables, we have various types of variables, and one interesting type of variables is Boolean variables. They should always answer the question, is it true or false? Sometimes it is good to use prefixes like is, so is good, is acceptable, is positive, or prefixes like has or can. They can be very useful just to make the code a bit more readable. There are some good examples like has pending payment, customer found. I would often prefer to rename it is customer found, because in an if clause it's a bit more readable when you're reading if is customer found than if customer found. But it is still clear, so you can use either valid address or is valid address, positive balance or is positive balance, is prime, and other examples. Incorrect examples would be not found, run, program stop, player, list. Well, neither player nor list can answer the question, is it true or false. Is not found is not a good example, because it is a negativity contained in the Boolean variable. So if you look at the example above, where we have an if statement with is not found, it becomes if not is not found. Well, isn't it more straightforward just to say if is found instead of double negativity? So avoid double negativities and try to have positive names for your booleans. Also, names like can read, can write are good names. Naming special variables like counters would normally add a suffix count to a noun in the name, like tickets count, customer count. When your variable is representing a state, you can name it in a similar way, but with state as a suffix, like block bar state, thread state. Variables with small scope and span as an exception sometimes can have shorter names, like I, that we all know is being used for index within a loop, or index, or U if we have a unit, for example, that is being declared just a line above, so we know that U means unit. But by all means we should avoid as much as possible abbreviations and short names. So when we're dealing with temporary variables and naming them, Many people are tempted to call them temp or tmp, which is really a bad example of how to name temporary variables. In fact, do temporary variables really exist? Or can we not just say that every variable is temporary in the context of execution of a program? So why should we want to say that a variable is temporary? It doesn't really make sense. That's why, if we look at the example on the left, which is a bad example of using temp, why don't we, instead of temp, name the variable with something a bit more meaningful, like old value, new value, etc. So try to avoid temp and tmp, which you might have met in some examples online somewhere. They are not good examples. Length of variable names. Again, the same guidelines as before. How long could the name of a variable be? Well, ideally between 9 and 21 characters, but it can be less, it can be more as necessary. So it really depends on the variable scope and the lifetime of the variable as well. If a variable is more famous or more general for the whole class, it should have a longer name, usually, to be better qualified, so it have a more self-explanatory name. Therefore, acceptable naming examples you can see in blue, and unacceptable naming examples below in red. If you look at the example of class student, where we have private string last name variable, it is a good naming because the variable has a meaningful name. While if in the same class student we call a variable ln, that doesn't clearly imply that it is a last name. And the context of this variable ln is among the whole student class, and it would add a lot of unclarity to various methods that can assign values to it when reading through these methods. Other unacceptable naming examples are in a pair of lists to put a public variable called just I, which doesn't really make sense, a public property in this case, because that describes the contract of the class, properties and methods, and they should be named as concisely as possible. When to use prefixes and suffixes, what are the best practices? In some other languages, we know Hungarian notation is very widely used. In C#, this notation is not very popular, and it should be avoided as much as possible. The Hungarian notation normally describes the variable types by adding a prefix in front of the meaningful name. So for a combo box, for example, which is called multibyte, the name would be CB or CBX multibyte. But in .NET, we don't really need to do that. The Hungarian notations work well in other unmanaged languages like C++, so it's not completely useless, but not in the context of C# and .NET. Try to not use prefixes and suffixes to denote the variable type, and we had examples earlier with usage of list at the end or array list at the end of a variable, where array list was suggesting what type of object is used for the variable to be stored in. This is not really helpful. we very often want to refactor our code. From a list we might want to change to array list, to something else. So we shouldn't use the type and add it as a suffix at the end of the variable name. How to name properties in the best possible ways? Well, properties are a special type of variable which is part of the class contract. So similar to the methods, it should be put in Pascal case, and there are a few examples like public int length, public color, background color, public cache mode. So you can even have the same name of a property as the name of the type that it contains or returns, and public bool loaded. An incorrect example would be public int load, where load actually represents more action and is more appropriate for a method name, unless it represents the subject load, then it would be acceptable. When we are talking about how big is the load, then it is a noun and it is acceptable. But if we're talking about the operation load, then it is unacceptable. So it depends also on the context where this property is put, in what class is it put. Public color, background color, it would be a nice name if it were in a Pascal case, but it is in a camel case notation, so that's wrong. We should make the letter B at the beginning of background color to be uppercase. Public bool font, it doesn't really have any meaning to have the word font, which represents a subject, to answer the question, is it true or is it false? Yeah, you can say has font or is font loaded. That's good examples, but just saying font is inappropriate. And now coming to naming constants that we already mentioned several times. When we try to name constants, we use all capital letters and we delimit each word as part of our name, a variable name, with an underscore, because we know that all our variables, all our names in .NET needs to be all together as one word. So when we want to be able to recognize the different words being concatenated within one word or statement, we need to somehow delimit it. So in Pascal case convention, we delimit it in one way. For naming constants, we're delimiting it by having underscore. For read-only fields, we still use Pascal case, because in most of the cases they would be very similar to a variable describing part of the class contract. So there are a few good examples, like const int read underscore buffer underscore size for a value for the buffer size, public static read-only page size, default page size, which contains page size as a read-only variable, private const int font size in points equals 16. So that's all good examples, and here are some inappropriate examples, like public const int max equals 512, but it's not clear max of what. So we should define, is it max count or max reads or max underscore number, or whatever. Public const int buff 256 is a bad example because containing the value in the name of the constant is not very appropriate, because these values actually do change from time to time. So if we decided to change the value to something else like 1024, would we have to go and refactor all our code just to change the variable name to be called buff 1024? It's really a necessary effort, and it doesn't add too much quality. And in general, we should avoid values in the names anyway. Another not very good example is not very appropriate is constant called greater. It's much better if it were called greater underscore HTML underscore entity in this example. So it is clear that it is the greater HTML sign. Font underscore size. It's good to say that the size is in pixels or in points. And public const page size page. It's better to say that that's page size instead of just to call it page, because page is actually something much different from page size. And talking about bad examples, here are a few more of names that we should avoid. Like we should avoid the use of numbers in the identifiers names. Like, for example, a print report is a good name, but print report 2 is not a good name. So if you have two reports that you need to create, give them their own names, like print monthly report, print annual report, instead of calling them print report 1 or print report 2. Because in the future you might get in the middle print quarterly report, so your report number 2 will have to actually be renamed to report number 3, and it's not very meaningful. Exceptions from that, there are exceptions of course, are when the number is part of the name itself. Like, for example, RS233 port is the name of the port, or COM3 port is again the name of the COM port, so that clearly identifies a specific COM port, and it can't be named in a much different way. It has to contain 3. Win32 API functions is again a name of the API, so we should just use it the way it is. Try to avoid using letters from other alphabets, like in the examples below, because they don't really add quality and they don't make the code very good. Try to never give a misleading name, because the misleading name is worse than giving a totally unclear name, in fact. Consider a method that calculates the sum of all elements in an array. It should be named sum or calculate sum, but what about if it was named calculate average or max or check for negative number? That would mislead a lot the developer that is trying to understand what this method is doing and just continue reading through the code without having to deep dive into the method. Also be very careful when you do copy paste, because that's how most of the errors get introduced into the code. And don't blindly follow Microsoft. Sometimes they use really bad naming, as I mentioned earlier. For example, in their API libraries you can find situations where they've used names like navigate and navigate2 as methods, which is not really good naming. WNet add connection 3 method, which is not a very good name for a method as a whole, but also containing a number in it is making it even worse. Or a structure having all these underscores in it in the Windows 33 library. So don't follow them blindly, just try to think a bit yourself. Right, and as a further example of why we should not follow blindly, here is one code snippet which is a real example from the MSDN library about the usage of file stream, and you can definitely, I'm sure, recognize some naming conventions are not followed, and the code would be less clear than what we would need to put in a production code. But let's not forget that Microsoft don't have to emphasize on best naming practices in their code, because the purpose of these code snippets is more or less to show how to use a certain feature or a certain class, and its purpose is not to necessarily present it in the best naming conventions way. So therefore, don't just copy paste, but try to refactor the code so it makes sense. I'm sure you have seen probably code like that written in production, and it's not really nice when you have to maintain such piece of code. Okay, well, ending with that, we're coming to another interesting and exciting part of best coding practices, and this is code formatting. If we look at an example, which I'm sure will be kind of familiar to you if you have watched closely this video at the beginning, where we had a mixture of code which was unclear. So here is another example of that. So if you look at this code, it's really hard to say what it does, and it's even harder to say whether it does it properly or not. So have a look at kind of the same code being formatted better. This is again the example from Microsoft. So if you look at this code snippet with this code mixture, you realize how important formatting is. So let's talk about code formatting fundamentals then. What are the main purposes of code formatting? They are to simply improve code readability, and that on its side will improve code maintainability and reduce development costs. A fundamental principle of code formatting is that the formatting of the source should aid its logical structure understanding in the best possible way. And any formatting style that follows this rule is a good formatting style. Any other formatting would probably be not ideal. So here are some examples of how to format blocks in C#. We know that blocks are using braces to to format them, and the reason for that is the syntax of C#. So as we have to use braces for the compiler to be able to recognize that this is a code block, we have several ways of using them, but there is only one best practice of how to use them, and this is putting the braces alone on a line under the parent block, like in the example below under the if, and closing the brace again on its own line. And also the code within the block, inside the block, needs to be indented by a single tap. Here is something very important we need to mention. When you're doing indentation, always do indentation by taps and never do it by spaces. On some development environments, on some editors, the tap is represented by 5 spaces. On others it can be represented by 3 spaces. On third it can be represented by 4 or 6, and that can even be changed. For example, in Visual Studio there is the option to change how many spaces a tap should represent. Therefore, it's not a good idea to try to put 3 spaces, because if your colleague has a tabulation setting that is 4 spaces or 5 spaces, this will clearly misindent his code. How to indent methods? Well, they should also be indented by a single tap from the class body. Like if you look at the example below, the class code indentation example, the method called edit is indented from the class by a single tap. And also the method's body should be indented in the same way as a standard block as we showed on the previous slide. So it has to be indented by a single tap. Here it is. In methods declaration we also use parentheses, and it's a good idea to define some best practices around how to use them, because the compiler again allows us to use them in literally any way as long as the syntax is correct. So a recommended practice is that we use the parentheses in the method just right after the method name, straight after it, without any spaces on the left or right of the parentheses. So the top example is a good example how to do it. The example in the middle is a bad example where spaces have been put in between the parentheses. And as in if conditions, for loops and other places we are also using parentheses, the rules around that are the same. Method parameters should be separated by a comma, and it's best if it is followed by a space. Don't try to put a comma before the space. Try to do it as on the example with the blue code, and try not to do it like on the red examples, which are incorrect. So let's have a look through the bad examples. On the first one we have no space after the comma, so that's wrong. On the second example we have a space before the comma, so that's wrong as well. And on the third example we have a space before the comma, which is wrong, and a space after the comma, which is correct, but because of the space before the comma it is incorrect. So looking at the top examples again, we can see that they have been done in the way that we expect. When you have more than one method, it is a good idea to separate them by line, so it is clear where a method starts, where a method ends, and somehow it's more readable for the eye as well, to be able to separate each method to look like a separate block of code. So use empty lines for separation between methods. Here is the empty line in our example, and it really makes the method more readable. And another thing, as we discussed already, that braces should be used in any code block. Here we haven't used the braces, but it's recommended that you use them. This code will completely be compilable, but the braces will make it more error-proof in the future. We just haven't put them here because of the lack of space. Sometimes it actually helps to clarify the code when you put a few empty lines in the method body as well. So if in your method there are specific code blocks or code segments that you can put together, and it makes sense for anyone that is reading your code, including yourself in the future, to be able to very quickly see that there are different blocks, it's good to put empty lines to separate these code blocks. So let's have a look at the example. In the class code prepare reports, on the first line we have a definition of a list, and then it is separated from the next code segment, which is around creation of income reports. Then we have another empty line which allows us to separate the income reports from the expenses reports, and then we are returning all these reports at the end. But it's good that we are separating the return function, the returning line of code, from the segment of code that is addressing the creation of expenses. And as we're showing some good examples, here is a but example of how you can easily misplace empty lines, and the code would still be completely compilable, but it's far less humanly readable, and it makes the code as nasty as the picture here on the right. Okay. So when we're formatting types like classes, structures, interfaces, enumerations, we should always indent the class body by a single tap. Use the following order of definitions. It is advisable but not compulsory. You might find a better order that fits better for your project and for your organization. But the key thing here is that you have some order. So you know that where one method starts, you can find all the other methods, where you find the first property, you have a whole segment of properties underneath, and when the last property finishes, you don't have more properties. Let's have a look at an example of how to organize our code, which is starting with the static variables, then with the private members, then the constructors, then there is a property defined, and then a few methods. So that's one recommended structure, but the key moral here is to have your code organized and structured in a way that similar things are stuck together. Formatting conditional statements and loops, it is key that we always use the braces block after if, for, and while, even when there is a single operator. and we already mentioned that. Also, it is important to indent the block body after the if, for and while, because it is a block, so it is exactly the same as what we started with, that when you have a block enclosed by braces, you always indent by a tab. Never put the block after if, for, while on the same line, because that makes the code less clear. Always put the brace on the next line, as we discussed with the block, and never indent by more than one tab. And here are a few examples, like on the first blue example, everything is as we described according to the best practices, and the three, I wouldn't call them bad examples, because these examples would actually work and they won't be a problem, but they're not really fitting well within the notation of best formatting practices in C#. But here is on the first line, and on the first inappropriate example we don't have braces at all, which is not a good idea. On the second one, again, we don't have braces at all, and the code in the block, which we can't see because we don't have the braces, is on the same line as the loop. So that makes the line of code being very long often and not as readable as if it were better formatted. And on the third example, we have the first brace put on the same line where the for statement is, while in fact we would expect to have it alone on a separate line. And just to mention that this notation with the third example is used often in the Java world, so you can see it in the JavaScript, but not with C#. When you have a too long line of code, you have to do something about it, because it becomes unreadable. So we obviously have to split it, but in a way that the compiler can still compile it, and in a way that we can also easily orient within the split code and understand what it does. So we should always split after punctuation, like in the example below, where it is split after the logical OR statement. We should indent the second line by a single tab, as on the example below, and each subsequent line should be indented by a single tab from the start if statement. So it should not be further indented from the second line. Each subsequent line after the first should have exactly the same indentation. So there are two nice examples about doing that here, and if we have a look at some not as nice examples, you can see the same code being much harder to read and understand, because it's not well formatted. For some reporting purposes, people sometimes try to align the text output, and that might sometimes make them think that they should be doing the same with the code. In fact, this is not a recommended practice. We should not align our code, because any subsequent change that we might have to do on our code, or looking at the same code on another editor of another colleague of ours who has a different setup about alignments, about how many spaces a tab has, etc. The same aligned code might look quite misaligned on another screen. So there is no point spending any time on aligning that. Now, if we go to something even more exciting, and probably the most interesting part of this lecture, how to create high quality classes, how to design them in the best possible way using abstraction, cohesion. So what are the reasons, first of all, to create a class? Well, a class represents a good model of a real-world object, and it allows us to model real-world objects in a way that suits for our purpose best. Putting information in a class and creating a class reduces the complexity, because we can work at a higher level than just having a standard piece of code within the program and not structured under a class. It also allows us to isolate complexity and hide it within the class. So actually the class only exposes the certain interface to other classes that are really important to be exposed, and everything else remains hidden within the class. This in fact is called encapsulation, and is very important to be used as much as possible and properly. That gives very big benefits. Limiting effects to changes only within the class is another key reason why we want to create a class. So if some calculation is done within a class and the class offers a method calculate, this method knows how it does the calculation. So if we decide to make a change to the way a calculation is done, like to achieve better proximity or something else, we simply go and do that within that method, but the method still returns accurate values to its callers. So any changes within the method are done inside the class, and the class callers don't really need to know how the method does the calculation. They only need to know that when they call it, it calculates and returns the right value. Other reasons to create class is to hide the global data that a class has, like some data that is specific to the class, to be only accessible through methods or through properties in a way that it cannot be modified, for example, by external callers, but they could still have access to this data. And if something changes in the way this data is calculated, they still have access to the result of the calculation, which is the data itself. Also, having a class allows us to group related variables together so they can be used from within the same area, and it gives us central points of control, like a single task is performed at a single place. That really helps a lot to avoid duplicating code, and code duplications are actually a very bad practice, because when we have a code duplication and if a change is required or if refactoring is done in the first piece of code, its duplication needs to suffer exactly the same changes, and if they are not done properly, which often happens, then that usually leads to a bug. So that's why it's a good practice to avoid duplication and to facilitate code reuse. That's why classes allow us to define some methods for a certain action, and if there are other places where the same action needs to be performed, just they can call the method of this class so they can receive exactly the same result. And if there is a change, the change can only be done in this area where the class method is. What helps the code reuse is when we use class hierarchies, so inheritance and virtual methods, and also when we package related operations together. That actually increases the code readability as well and the code comprehension. So one of the ways to achieve high quality classes is to use a good abstraction. So if we ask the question, what abstraction is the class implementing, and does it represent only one thing, we can answer whether the class has been well defined and it has a good level of abstraction. Does the class name well describe its purpose is another way to know whether we have named it well and whether the class is only doing a single thing. Does the class define clear and easy to understand public interface or contract, which is for the class colors? And does the class indeed hide all its implementation details from the colors that are using its public interface? So when we achieve all that, we have good abstraction. And here is an example of good abstraction. In this class called font, we have several properties which are public, like name, sizing points, style, and we have a few methods like font. Indeed, this is a constructor which properly initializes all these properties like name, size in points, and style through members that these properties use. These members are not appearing on the example, but let's assume that they exist. And it also defines a method called drawString, and it also defines a method measureString, which returns the size of a string. So that's a fairly good example for high quality class. And here is a bad abstraction example. So as we mentioned earlier, one of the reasons to define classes is to put several related tasks together. But in this class, which is called program, we have several sets of related tasks together, and we should actually isolate these sets of tasks into separate classes. Let's have a read through this code. So we have member called title, a member called size, a member called color, and we also have a method called initialize command stack, push command, pop command, shutdown command, and these are all about commands. But title, size, and color have nothing to do with commands. So that's two different types of data, and they're quite unrelated. So it doesn't really make sense to use them under the same class. Also, if we proceed further down, we have methods for initialize report formatting, format report, print report, and that's again completely different from everything else, completely different from commands, completely different from title, size, and color. So that should also go under its own class, like maybe report utilities, and the command class could be called command utilities or something else. Initialize global data, shut down global data. Again, that implies something completely different from the other areas. So does this class really represent a program? And is that a good name? I don't think so. Does it really have single purpose? No, it doesn't. Therefore, we should make sure that we refactor it and we define the several necessary classes from it, which would give us the appropriate representation of the data. So to establish good abstraction, there are other things that help further, like defining operations along with their opposites, and as previously mentioned in this video, using the opposites well together instead of using other words. Like in the example of open and close, instead of dissolve, for example, where dissolve might close the connection, it's always better to call them open and close, so it is clear that they do the opposite of each other. Get, set, load, unload, and other examples I'm sure you can find. Also, unrelated methods should be moved into another class, like we had here in the example. All the methods that were around common stack, they should be altogether removed from this class and put into a new class that is responsible for commons. Another example that we might be interested to discuss is, let's imagine that in the class employee we want to calculate the age. It makes sense that the age is calculated by some type of date utility class, by given date of birth, so it can actually measure the difference between the date of birth and today's date, and it can produce some accurate results that it can return to the employee class. This is just as one example, and there are many similar examples that we can identify, and we'll discuss them a bit further. When we make any changes to classes, we have to be very careful not to break the interface abstraction. And a good example of breaking the interface abstraction is if in the class employee we added a method which should be normally kept in the database access layer, and this method actually performs database access operations which are not typical to the class employee, which should normally just contain some information about an employee and not directly call the database. So that's a good example of what we should not be doing. Another very good technique is the encapsulation, and we'll talk a bit more now. It allows us to minimize the visibility of classes and members, and basically that allows us to make visible only the members that are necessary to be visible. Any calculations, any results of these calculations, any temporary data can be kept as private, and that allows actually to keep the control of the code within the class. So a good practice for encapsulation is always to think what of your properties or members should be public. And anything that shouldn't be public, it should first be made private. If for some reason you need it to be not private, but you're still considering it that it should not be public, try making it internal, or if you just want to use it within any potential inheriting classes, make it protected. Remember, good encapsulated classes are less complex, much easier to maintain, and much more loosely coupled. Don't try to violate encapsulation semantically by using any non-documented internal behavior or side effects. Example of that is to avoid the calling of connect to DB method just because you know that inside find employee by ID method there is a connection opening. So in the future that might change, so have that in mind. Try to not hide methods in subclasses, like for example in the timer class, if you have a private method called start, if you try to define in an inheritor of timer same method called start, it will actually hide this method. Move common interfaces, data and behavior as high as possible in the inheritance tree. That maximizes the code reuse you're going to get. Be cautious with base classes of which there is only one derived class. Ask yourself, do you really need this additional level of inheritance? And if you don't need it, or if you're not expecting to need that in the future, just combine the two classes in a single class. Always be cautious with classes that override a routine and do nothing inside. Always ask yourself, is that routine overriding done on purpose or was it done by mistake? Avoid deep instance trees. Don't try to create more than 6 levels of inheritance. It will make your code far too complicated. Avoid using a base class protected data fields in a derived class. Better provide protected accessor methods or properties instead of doing that. Always prefer inheritance to type checking. So if we look at the example here, the shape class obviously has two methods, draw circle and draw square, which are being called depending on the shape type. A better way of doing that is if you create two classes inheriting shape, one for circle and one for square, and just override the method draw into these classes. So the circle performs the draw circle action and respectively square does the draw square action. When it comes to class methods and data, keep the number of methods in a class as small as possible. That will reduce the complexity. Minimize the direct method calls to other classes and try to minimize indirect method calls to other classes, so via different methods. Less external method calls actually means better loose coupling. Minimize the extent to which a class collaborates with other classes, and you in this way reduce coupling between classes as well. In class constructors, initialize all member data in all constructors if possible. Uninitialized data is error prone. Partially initialized data could be even worse, so you have to be very careful when you have the opportunity to miss to initialize data. Always try to initialize data members in the same order which they are declared in. That will allow you to not miss to initialize any. And prefer deep copies to shallow copies. When possible, and with the knowledge of design patterns, try to use and apply them. For example, use private constructor to prohibit direct class instantiation when this is necessary. This is often used with a singleton design pattern, for example. You can use design patterns for common design situations, and that will help you resolve these situations in a successful way, and also anyone else that knows design patterns would understand why you have done this approach. Design patterns are three main types: creational patterns like singleton, factory method, abstract factory and others; structural patterns like adapter, bridge, composite, decorator, facade, and I'll miss a few; behavioral patterns like command, iterator, observer, strategy, template, method and others. All these you can find in Wikipedia or additional articles online. Always try to use the appropriate namespaces for your code, for your classes. Just for example, if you have a utility namespace, put all utility classes in that namespace. And here we go. We're coming to the live demo session on code refactoring, which due to this video becoming over 2 hours now, I've decided to move into a separate video session, which will be a hands-on code refactoring that I'm going to do for you. So please check out the other video that is coming on code reformatting. And at the end of this video, please have a look at the resources. Don't forget to check the high quality programming code course at Telerik Academy at the link codecourse.telerik.com. Also, when you have a chance, read the Code Complete book. It's a fantastic book written by Steve McConnell, published by Microsoft Press. It is the Bible of high quality software construction. And finally, if you have any questions, please don't hesitate to send me an email, and whenever possible I'll try to reply. Thank you for watching this video. My name is Hristo Radkov, and it was my pleasure to spend some time with you.